Hello everyone, my name is Faith Ekstrand. I'd like to welcome you to my Nouveau/NVK update for XDC 2024. For those of you who don't know me, my name is Faith Ekstrand. I can be found on Mastodon/the Fediverse at that address. I have been around free desktops since about 2013, and I actually started out in Wayland. Shortly after that, I joined Intel on their Linux graphics driver team, where I worked on the OpenGL drivers. I helped build the No Optimizing compiler in Mesa. I wrote most of the Intel Vulkan driver, as well as the SPIRV to No Translator, ISIL, and a number of other Intel bits, and then I served as the Vulkan driver maintainer and also was the one of the Vulkan representatives in Kronos during that time for Intel as well. I've been at Collabora since 2022, where my role is to basically float around the entire Linux graphics stack wherever is needed and do whatever is needed. My project the last few years has been to try and reboot the Nouveau user space in the form of writing NVK. So before we get into NVK, which is the primary thing we're going to talk about, we should talk a little bit about the Nouveau kernel. So most of the last year has been bug fixes, and the bug fixes have been substantial. We've fixed a lot of stability issues, we've fixed fencing issues, we've fixed memory eviction issues, and Nouveau is a lot more stable today than it was a year ago. There are still issues. The GPU in my laptop does like to fall off the PCI bus sometimes, especially around suspend and resume, but it is much better than it was a year ago. I can do a full CTS run on 36 threads on my desktop, and it does not bring down the kernel most of the time. There's still some weird issues around the GSP we're figuring out, but it's much better than it was. The other big thing that's happened is that the GSP firmware support has merged. So as of my last talk, the GSP firmware was still patches on the mailing list, and now everything is merged, and the firmware is in Linux firmware, and it is shipping in your distro. If you've pulled in a Linux 6.10 kernel, that is actually a pretty good kernel to run Nouveau on, and I can do my CTS testing on it. That's most of what has happened, but there's something else. So Red Hat, a few months ago, announced the Nouveau project, and this is an effort to rewrite the Nouveau kernel driver from scratch. And if you've poked around the Nouveau community for a while, or you've poked around the kernel driver, there's some definite architectural issues with it that have been causing us a lot of headaches. And this is a from scratch rewrite. It's going to be written in Rust, and they're going to be reusing or sharing a bunch of abstractions with Asahi. So Lena has put together a Rust kernel module for the Asahi project from M1 Silicon, and a bunch of her abstractions. They're working on upstreaming. They're also adding some abstractions that are needed that weren't there before, and trying to get to the point where we can do upstream Rust DRM drivers. Lena has done some amazing work, but it's one of those things where in order to really drive upstream, you need multiple consumers. And having Nouveau as one of those consumers is a good way to help drive the upstream efforts. It's also going to give us a new kernel module with hopefully better architecture and more stability. The new kernel module is going to be GSP only, so it's only going to work on Turing and later cards. They're not going to try and hook up the old firmwares. That's going to simplify a lot of things internally. It also means they can toss a lot of old hardware that doesn't have things like per-process page tables and a lot of that stuff that we take for granted today. Nova is still in the very early development stages. I'm not going to provide a link to a branch where you can test it out because you can't test it out. There are some bits of display that work, but the driver is itself you can't run GL on top of. Yeah, but it is in progress, and they are making progress. Okay, let's move on to NVK. So a lot has happened in the last year. So this is going to be a blitz through what's happened in NVK in the last 12 months since XDC 2023. First thing to note is that we are now a Vulkan 1.3 implementation. We are now a conformant Vulkan 1.3 implementation. Last year, during XDC, I was working on trying to submit Vulkan 1.0 conformance. We had all the 1.0 features, we were passing all of the tests, and I was actively babysitting CTS runs from my hotel room and from the conference room, and finally did the submissions the last night of XDC. In February, I was able to submit 1.3 conformance. And we are now a conform 1.3 implementation. We've also implemented a lot of features. This is kind of a PowerPoint faux pas, but I like to do it because it shows off just how much work has gone into NVK in the last year. There's some 90-some items on this list. And this includes everything needed for DXVK. So this was a big milestone when we finally closed the DXVK tracker. There might still be bugs, there might still be performance issues, but we're not missing any features required for any DXVK app. We also have everything that Zink needs in order to expose OpenGL 4.6. Again, this took a lot of work. We're going to talk more about Zink later, but there were a lot of features that went into this. And now Zink has everything it needs, modular a few extensions that can turn on some optional things, but for the most part, everything in 4.6 and most of the features anybody cares about for OpenGL are now available through Zink. We also have done most of what's needed for VK-D3D and D3D12. We're still missing a few things, so ray tracing is missing. That's a big piece of work. I probably am not going to crack into that in the next year. I'm kind of hoping somebody from Valve comes along and picks it up, but wink, wink. We're still missing fragment shader interlock. That one's a tricky one. It's basically a fragment. It's basically a lock that you implement in the fragment shader per pixel or per sample. So you have like an image that has one pixel for each sample, and that image is where you implement your mutex. And then there's an ordering bit to tell you which thing should win the attempt to take the lock. We're also missing fragment shading rate. That one is much easier. There's hardware for it. We just have to wire it up. But it is reverse engineering work that hasn't been done yet. And finally, mesh shaders. And Mary is working on this. She has a talk at XDC this year about it. There's still some annoying compiler things we have to do because of the way that the mesh shader limits interact with NVIDIA hardware. But she is working on it. The other big thing that happened is that the new compiler now supports everything back to Maxwell. So we wrote the new compiler. It's a lot better than CodeGen. It still has bugs, but it doesn't have as many. And for a while, it was Turing only, or Volta only, and above. And now we support all the way back to Maxwell. This means two things. First is that we can probably delete CodeGen support from NVK, and I will likely do it soon. If somebody wants to bring up Kepler, they're more than welcome to, but at this point, I think trying to bring up Kepler, the first suggestion is going to be to bring up the compiler, because there's just no point in trying to run NVK on the old compiler. It would also allow us to clean up NVK and remove all of those places where we have multiple conditions based on what compiler you're using. It would make things a lot cleaner. The other thing that this means is it means that the compiler now has the infrastructure for multiple generations of NVIDIA hardware. And this means that we're ready for whenever NVIDIA throws a new instruction set at us. It took a bunch of work to get these abstractions right, and eventually we did, and it also improved the compiler for Turing as well, because the abstractions turned out to just be a good idea. And with all of this, there are lots of games working. So we thought we would put together a little demo reel for you. I got some screenshots and some video captures from some users, so we'll go through that quick. So here is Horizon Zero Dawn. You saw a still in the beginning of my talk, but this is the benchmark running. Here's Cyberpunk 2077. This was a very big title a few years ago. Frame rate is not great, as you might be able to tell, but it is running and it is rendering correctly, which for Cyberpunk is a bit of a miracle. Here's X4 Foundations. Transport Fever 2. Rust, which is a game I've never played, but it looks really pretty. Here is Deep Rock Galactic. I'm not sure what's going on here, but it is rendering correctly. It's running at a decent frame rate. Return to Monkey Island. The Witness. So this is one that we've actually used quite a bit in our testing because it's very, very stable frame rates. And so it's really good for testing whether or not your performance change makes any difference, assuming it affects the Witness, that is. Because you can open up the same scene over and over, and it basically gives you exactly the same frame rate. So we've actually been using it quite a bit for our testing. Here's Evil Genius 2. And finally, Super TextCut, everybody's favorite. It's not the most complicated Vulkan renderer in the industry, but it's fun, and it's nice to see that it's running at a nice, smooth frame rate. Okay, so before we wrap up, let's talk about Zink. I promised you we'd get back to that when I talked about OpenGL 4.6 conformance, and we should do that. So we are OpenGL 4.6 conformant. Not only do we have all the features in NVK, but we actually fixed all the bugs, and we got Zink passing conformance. There were a few NVK bugs, there were a few Zink bugs. I think NVK ended up winning in the end, but we got everything fixed, and we're passing OpenGL 4.6. There's also some of those features that were pretty important for Zink, and I want to highlight some of those. First is DRM format modifiers, and this one is important for anything having to do with the Windows system. If you work on Windows system stuff, you're very familiar with this extension. And in Zink in particular, it lets us move off of the old Vulkan WSI-based path to the copper path. And the copper path is where Zink basically acts like any other GL driver talking to the Mesa DRM framework, to the Mesa EGL implementation, and just passes around DMA buffs, passes around modifiers, passes around semaphores. This display path is a lot more robust. We had to do this before we could pass OpenGL 4.6 conformance because we had lots of EGL issues with the old path. It's much more robust. The other thing that's really important about this path is that this is the path that allows you to run Zink as your compositor, as the OpenGL driver for your compositor. With the WSI path, basically it's just using the Vulkan WSI stuff, and it can pass images off to a compositor, but in order to actually be the compositor, we need the copper path. And we have that now. We also implemented shader objects and pipeline libraries. Those are very important for DXVK and VKD3 Proton as well. But for Zink, they were very important in letting us avoid a lot of stuttering and get onto some of Zink's fast paths. We also implemented descriptor buffer, which Zink uses to improve CPU overhead in its descriptor paths. Juggling Vulkan descriptor sets is a pain. It could potentially do better, but it's not quite there. But it's easier to use descriptor buffer, and that gets us fast. Also, multidraw, which is a extension that was developed for Zink that moves the internal loop when you're doing lots of draws in a row inside the Vulkan driver and improves CPU overhead. So, is Zink ready to be the primary OpenGL driver on your desktop? That's the question everybody is asking, and we're still working on it. So there are some issues. Here's one that's open where Chromium slowly corrupts if you have Discord running. We don't know why. We haven't tracked it down yet. There's probably some sort of a clearing issue or some sort of a dirty tracking issue somewhere. We haven't figured it out yet. Here is a picture from a user who I think is at XDC this year, showing the standard tiling window manager experience with NVK+Zink right now. There are multiple tilers that experience this, where you get lots of shadowing and corruptions. KDE mostly works, GNOME works, but there's still issues. Red Hat, we've been talking, and they want to give it a crack and see if they can fix the issues, because we kind of need to get it out in the world and get users testing it. And the best way to do that is to make it either the default or make it easy to make the default on your system. But that's going to be touch and go for a few years as we get all the bugs worked out, and we may try and pull it out and then try and pull it out again until we get it working. So that's the end of my talk. Thank you very much for watching, and I look forward to chatting with you all about NVK in Nouveau in the Matrix server. Thank you very much. So Tegra support is an interesting question right now. NVK doesn't actually work on Tegra, so we have enough user space hardware support, but the kernel side of Tegra is very, very different. And in particular, the way you do synchronization on Tegra is very, very different, and there's currently bugs there, so the GL stack does kind of work today. But the Vulkan stack doesn't properly because the synchronization stuff is busted. In terms of Nova, I don't know that we have solid plans there. The Tegra chips don't actually use GSP, so that's, or at least the ones we're familiar with don't. It's possible that will change with whatever Blackwell-based Tegras they decide to ship, or some of the newer stuff, but it is Tegra's kind of in an awkward spot at the moment. I do want to see it get fixed, but it's not received a lot of love.
Thank you. Hey, I just wanted to add one. I think the very first version of the driver that got NVIDIA's OpenRM, like their open kernel module rewrite, was a Tegra. I could, but I'm pretty confident that the Tegras that I'm familiar with do have GSP. Maybe there's an older one that doesn't, but we're talking about the single board computer, right?
Yep.
Yeah, I believe there is a
So
GSP for that.
it's possible that the Orion and the other like Turing plus ones
Yeah, the
are,
Orion
but
definitely does.
yeah. So in that case, we'll probably try to support it with Nova, but again, the plans there are still very TBD.
If someone was going to come along and implement VirtIO GPU native contexts for NVIDIA GPUs, should they implement it for Nouveau or should they wait for Nova?
My gut feeling is that trying to do it in the current Nouveau module is probably more trouble than you want to get into. But I'm not deep into how the VirtIO stuff works in the kernel to know how surface level it is. If it needs deep plumbing, I would probably wait. I would definitely like to see that happen. Then it might be practical to hook up, but again, ioctals are not as straightforward and obvious as you might like to think they are. But I wouldn't stop somebody who wanted to try. Put it that way.
Also, is the Nouveau module reasonably secure against buggy or malicious user space that's not the compositor, or will that also need to wait for Nova?
It's definitely better than it was, but there's still some things we don't understand about the GSP that make it pretty easy to take down if you hammer on it hard enough. I don't have a good sense for how insecure it is. I mean, there are definitely worse drivers on that front, but hopefully Nova will improve that. So I don't know, if somebody's trying to get like some basic I want to run a game in a VM stuff working, I'd say go for it, but long term, I don't think anybody. I think at this point, the old Nouveau kernel is basically in maintenance mode. We're not looking to add a lot of stuff. Maybe prototype some stuff that we plan to do in Nova there, but if it's major effort, it might be better waiting.
Okay.
It's hard to tell.
Hey, you said 1 second ago that there were some things you're still trying to figure out about the GSP. Do you have some specifics on things that you don't yet know about the GSP?
It's some debugging work. So right now, if I do probably 1 in 4 CTS runs will cause some sort of GSP fault, and
Okay.
then it'll give up and my code will just effectively fall away.
Okay.
I don't think we know what's going on there. It's not a big thing. It's more just there's probably some piece of memory that's not big enough.
Okay. I wrote a reverse engineering project on the GSP and the NVIDIA OpenRM driver. I think if you Google OpenRM, it's like the second result. If you want to, I'll look you up after this and I'll try to find your email and send you an email. But if you're interested to try to figure out what's going on with the GSP, I might be able to help you with that.
Okay.
Okay, cool, thanks. Oh, and all the different functions that I've been able to figure out so far are on that page. So if you do take a look, it might help.
Hi, Faith. It's Mark. I love the sunglasses, by the way. They're awesome.
Thank you.
We have our very first online question of XDC this year. So someone asked, what are the current main performance blockers for NVK?
Unknown. There's definitely some stalling issues. There's definitely places where we could do descriptors better. A lot of it is just that I have spent almost no time working on performance stuff and need to actually sit down and focus on that for a few days, a few weeks, and try and knock some stuff out. I think most of the pieces are in place to implement things right. It's just a lot of triage work at this point and trying to figure out what's going wrong. There's a few smoking guns, but for the most part, it just needs time and effort. Thank you.